All right, 4.5, solving trig. Something that is helpful to have is this right here. It's a trig table, so it's all of the things from the unit circle, so the x values, the y values, y over x, the reciprocals, and so forth. So that's just handy to have to snap a picture of. Let's get started. First off, you can always solve graphically. So if you remember Algebra 2, there was a big push to always solve graphically. So if I were to do the sine curve, and in fact, I could even repeat the sine curve again, everywhere that it crosses 1/2, because sine is 1/2, is the answer. Now, that repeats every 2 pi. But it's kind of hard because it's a decimal. So graphically isn't my favorite, but I bet you Desmos is actually probably pretty smart on that. I have not tried it, but go right ahead. You could also think about looking at the unit circle. So if I look at, this problem, I have cosine x equals 1/2. How did I get 1/2? I added 1 to both sides, and then I divided by 2 on both sides. So cosine x equals 1/2. So I'm asking myself, at what angle is cosine 1/2? Okay, the other little cheat is to go up here and find in the cosine column, where is it 1/2? So that would be my answer. There's another place where it's 1/2, so that would be another answer. And that would repeat every 2 pi. Okay. So I'm just going to do a couple so that you have examples. First one's collecting like terms. So that means that I'm going to subtract cosine x, the 14 cosine x from both sides. I'm then going to add 7 to both sides. That way I'm left with 2 on this side. I'm left with 4 cosine x on this side. Divide by 4. And I get cosine x equals 1/2. Well, we've already talked about what that was. That was pi over 3 and 5 pi over 3. So again, using that chart, where cosine is 1/2, what is the radians? It was 5 pi over 3 and pi over 3. At some point, if you do this often, you would have this memorized and not need that chart, but that chart is very helpful. So this is my answer when I say between 0 and 2 pi. If I want the general form, meaning that it could be anything, I would do pi over 3 plus 2 pi n. That means that I could go around 5 times, still be at the same spot, so therefore the same answer. I could go around -4 times, be at the same spot, therefore the same answer. And I would write that for both of them as just the general form. Okay? Keep rolling. This one works the same way, so I get 1 over 3, but since it is squared, I undo a squared by square rooting. And here is what everyone, okay, not everyone, but there's always multiple people in my classes every year that forget this. When I take the square root of something, it's both positive or negative. Okay, so the square root of 1 is 1, and the square root of 3 doesn't really simplify, but I can rationalize it so that I get tangent x equals positive or negative square root of 3 over 3. So go up to my chart. Everywhere that tangent is square root of 3 over 3 or negative square root of 3 over 3. So notice there are 4 places where that could happen. So that's at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If I wanted to write the general equation, it would just be pi over 6 plus pi n. Notice I did not put 2 pi there. because tangent repeats every pi, which is why I only have to put these two as my answers, because 7 pi will be picked up when I plug in 1 as n. 11 pi over 6 will be picked up whenever I plug in 1 as n. Okay? Next, it gets a little harder, and this is because some of us are not super advanced in our algebra skills like we should be. So I look at my two terms. I notice that they have sine x in common, so that means I'm going to factor out sine x, and then I'm going to put my what I call leftovers on the inside. Okay, so now I have two things being multiplied together. The zero product property states that as long as one of them is 0, this will hold true. So where is sine 0? Well, that's at 0 and pi. Simplify this one a little bit to get cosine equals 1/2. Where is cosine 1/2? That's pi over 3 and 5 pi over 3. So all 4 of these would be answers when you're talking about between 0 and 2 pi. All right, 2 more problems and we're going to call it a day. This one involves factoring. So 2 sine squared x minus sine x minus 1. Think of that as 2a squared minus a minus 1. If I were to factor that, it would be 2a and a. I know these are 1s, and then I have to decide which one's positive and which one's negative such that I get a negative in the middle. Okay, so that's just factoring. If you did that snowflake, if you do that with box method, use whatever method you have for factoring. But instead of a, I should actually have sine x. Just like the last example, I could set them each equal to 0. So I get sine x equals 0. Sine x equals negative 1/2. Where does that happen? I have quit scrolling up to the box, but this is where you pause and make sure that you get those answers. But sine is negative 1/2, so the y value is negative 1/2 at 7 pi over 6 and 11 pi over 6. And made a mistake there, so hopefully you caught it already. This should be 1. Therefore, x should equal pi over 2. So all 3 of those are answers. Okay? And the last one. So how are multiple angles different? Okay? So for multiple angles, you still kind of think of it as where is sine 1/2 at? And that is at pi over 6 and 5 pi over 6. But that's usually what x equals. Well, now it's not x equals that, it's x over 3 equals that. Okay, so if x is being divided by 3, I multiply by 3 on both sides. And when I reduce, I get 5 pi over 2. And here I just get pi over 2. Okay, now I am only on the interval between 0 and 2 pi. This is greater than that, so this is my only answer. Okay, this would work if it was going on forever, but since it's only between 0 and 2 pi, remember 4 pi over 2 is 2 pi. So if I have 5 pi over 2, that is greater. So we will practice some more, but it's just taking the skills you already know and putting them on a little bit of an advanced level.